I cannot stand on a podium for the life of me, so I have to move around. We'll see how this goes. It could be a little awkward. So I am now based in San Diego, which means that I have been doing too much of this and not enough of preparation for my talk, but we'll see how this goes. This is foiling, and that is an electric foil board. And I was out with my friend Dylan, who's in the audience yesterday, riding this in a lagoon when I was supposed to be working on my slides. But regardless, we made it. So this is me. My friend Tommy Wood, who was a presenter here, gave me a little bit of a razz. He said, "Paul, your profile, your bio doesn't have anything about you being a carnivore doctor. What are you trying to hide it?" And I thought, okay, I should just come clean from the beginning. So this is my real disclosure, that I am a strong advocate for the carnivore diet, and this is my website. It's carnivoremd.com, and that's me. So many of the things in this talk are influenced by my perspectives on ancestral health, and I am super excited about humans eating lots of animals. I'm writing a book called The Carnivore Code. This is not the actual title or the actual book. This is the actual title. This is not the actual book cover, but it was one of the original mock-ups, which was kind of fun. So, all right. So when people think about a carnivore diet, they often ask me, they'll say, you eat all meat, right? A carnivore diet is just an all meat diet, right? And I say, no, there's so much more to a carnivore diet than just meat. And that's what I thought would be fun to talk about today in this talk. Specifically, what I thought I was going to talk about was animal fat and the importance of eating animal fat, sort of the unique nutrient value of animal fat and how it's been kind of maligned unjustly, and what we're missing when we're not thinking about intentionally incorporating animal fat into our diets. So much more than meat. And what ended up happening in this talk was I also had to talk a little bit about organ meats. So really this talk is mostly about fat. I'm going to talk a little bit about organ meats, but all sort of ancestral themes about pieces of the animal that we don't often think about, whether we're eating carnivore, ancestral, primal, etc. But the carnivore diet and ancestral diets are definitely much more than just meat. Fat and organ meats are a critical part of ancestral diets. So this could be my whole talk, this one slide. Which steak would you guys choose? It's just, I think it's fairly obvious, but how many people would go for this steak over here? So how many people would eat the Wagyu steak? He wants both. You can only get one. You have to feed the dogs something. How many people would eat the sort of the very lean sirloin? Okay, so a few. And it'd be interesting to hear why people would eat the lean sirloin versus the fatty one. But at least I would say 85-15, based on the survey, would go for the fattier steak. And I think this is an interesting finding, that we are sort of humans, we are programmed to seek fat. And that is what this talk kind of began with, the notion, the curiosity that we do seek fat as humans. That steak just looks more appealing to us. We know that the protein in this meat is valuable. We know that there are value in the lean steak, but as humans, we really sort of have this fatty steak programmed deep into our brains. So on my YouTube channel, which is just under Paul Saladino, MD, I did an interview with Miki Ben-Dor. He's a great guy, a good friend, and he's written some really cool ethnographic studies. He's a paleoanthropologist from Israel. This is one of the coolest articles that he sent me that he wrote. Just the title is awesome. Use of fat, animal fat, as a symbol of health in traditional societies suggests humans may be well adapted to its consumption. You'll see here at the bottom, fertility, sacredness, wealth, health, even a source of creation in life were associated with fat in traditional cultures. And in this article, they looked at over 200 cases from a very culturally and geographically diverse selection of societies. They perceived animal fat as a vital component of their diet and a profound source of health, rather than an impediment to health, as is presented in many dietary recommendations today, which drive me crazy. But this idea that ancestral peoples have always been seeking fat is such an interesting idea. So furthermore, in this article, they talk about a few specific instances. This researcher, Speth, came to the conclusion that fat, not protein, seemed to play a very prominent role in the hunter's decisions about what animals, male versus female, females presumably being more fatty, to kill, and which body parts to discard or take away. They were seeking fat. Humans preferring to hunt prime adult animals over the more vulnerable and easily obtained young or old animals, because the old animals had more fat. Younger animals are smaller, they have less fat, and as we will see, when the animal has less fat, it's really not as valuable to us as humans evolutionarily. So this is also from the same paper by Miki Ben-Dor, the ikung of the Kalahari, which is the first picture there. Fat animals are keenly desired. All ikung express a constant craving for animal fat. The Cree Indians considered fat the most important part of any animal. I would probably agree. They valued bears because the bears were super fatty. And then this Aboriginal population, they will seek the animal fat, and if they don't feel the animal's fat, they will just leave it. They'll be rejected as food even if they've hunted it. So we have this ancestral programming, we have this ancestral lineage of seeking fat, seeking the fattiest animals throughout many cultures in our history. This is one of my favorites. So this is an Andean Indian culture, and the word that they use, I am not exactly sure about the pronunciation, but it's WIRAQOCHA. And that means, it's a greeting, and literally it means a sea of fat or plenty of fat. And so basically when they're greeting each other and saying hello or goodbye, they're saying, I wish you a sea of fat. I hope that you are engulfed in a sea of fat. And I think that's so cool. They also have the same name for the main god, WIRAQOCHA. And so their god, their main pantheonic deity, is associated with a sea of fat. So their god is sort of just drenched in fat. This idea of fat as the key survival nutrient is embedded in this culture as well in such a poetic way. The Fat of the Land is a great book by VILHJALMUR STEFFANSON. Many people are probably familiar with him. This is a quote from that book. And the quote from that book references a quote from Genesis where Cain and Abel brought sacrifices to God. And unfortunately, unfortunately, Cain brought vegetables, and God said, and Abel brought fat and an animal, and God said, okay, I'll take that. So, I mean, you know, this is sort of tongue-in-cheek, but even in biblical references, there are ideas that we have treasured animals and animal fats uniquely throughout our evolution or throughout history. So this is just a more basic version: accepted, rejected. Don't bring vegetables, bring animal fat. Another one of Miki's papers, he really even dubs man a fat hunter and says that with this transitional part of our evolution, when Homo erectus went extinct and perhaps more relatively recent incarnations of the hominin lineage, specifically Homo sapiens and others, moved onto the scene in the Levant Valley, which is the Levant area of Africa, we began having to hunt fattier animals as the elephants went extinct. For much of our human evolution, it's believed that we could hunt elephants and megafauna, which were basically big sources of fat. But when the elephants went extinct, we had to find the fattiest animals. We still needed that fat for evolution. We had to find the fattiest animals, and we really became fat hunters in a specialized way. This is a fascinating graph. So this is millions of years along the x-axis and size of the brain in terms of cc's on the y-axis. And as you can see, there's this fascinating concept that for millions of years predating humans, our primate ancestors had essentially the same size brain. And you can basically think about it this way. Our primate ancestors had 30 million years to grow a bigger brain eating vegetables, eating leaves, and it didn't happen. And then something happened about 2 million years ago, and the human brain started to explode. This exponential growth in the size of the human brain happened right about 2 million years ago, and that correlates directly with stone tools and hunting. So my premise, my suggestion would be that hunting made us human, and the actual onset of consumption of animal products in large amounts because of our ability to hunt contributed directly to this massive increase in the size of the human brain 2 million years ago. Some people would argue it's fire, but the archaeologic data on fire is much less clear. People date it between 1.5 and 500,000 years ago, which clearly, if you look at this graph, based on skull volumes, the human brain was already exploding in size at that time. And I suspect that it's the stone tools and hunting that were the real key that made us human. That is access to animal fat. Now, why is fat so important? I would say fat is important because fat is the nutrient that we need the most in the setting of not being able to overconsume plants or protein. So I think that there are physiologic limits to consumption of protein and carbohydrates coming from plants, and we'll talk about both briefly. So are there limits Are there physiologic limits to protein consumption? Absolutely. There's a picture of a rabbit because I'm referring to rabbit starvation here. So this is a really interesting paper, and in this paper, the authors discuss the idea that there are dangers of excessive protein, which they define, and many people have defined, as dietary protein being more than 35% of our calories as a human. When we get to more than 35% of our calories coming from protein, we run into this realm where we can kind of dance, or we start to tiptoe into the dangerous realm of hyperaminoacidemia, hyperammonemia, so too much ammonia in the blood, hyperinsulinemia, nausea, diarrhea, even death. There are historical cases of rabbit starvation when people can only eat lean meats. This is a historical term that refers to the fact that when we are only eating lean meats, that would be small animals or young animals or rabbits, squirrels, they don't have enough fat. We're reliant exclusively on protein. Protein then becomes a large part of our calories, and that leads to metabolic derangements, specifically, mostly this hyperammonemia. The liver cannot do the urea cycle to the degree that is needed to process the nitrogen groups in amino acids, and you get spillover and you get ammonia, and then you get all sorts of negative metabolic consequences arising from that. So there is a physiologic ceiling to how much protein we can eat as humans. We cannot simply just eat animal meat all the time. This is a really interesting graph. And on the vertical axis is the mean rate of urea excretion, and that's a genetic predisposition of how quickly we are able to excrete urea. And on the y-axis, or the horizontal axis, is body weight. And so you can look here, in the middle, say someone has an average mean rate of urea excretion, which again is probably a genetic determined thing, and I probably weigh between 70 and 80 kilograms. So for someone my size, 236 or 261, somewhere between that is probably what my body can do in terms of protein. If I exceed that, I'm looking at hyperammonemia. So there is my easily reachable protein threshold in a day with this equation. So I could easily get to that, and that would probably be pretty close to 35, 40% of my daily calories from protein. I'm going to push into hyperammonemia. I'm going to push the urea cycle to an overflow position, and that's not a good thing. So everybody's going to have a little bit of difference. There are other polymorphisms that might move us up and down the vertical axis there. For instance, I think I have an ornithine transcarbamylase, which is an OTC polymorphism. We don't have to go into that today. But I think that I actually have less, personally speaking, I have less of an ability to excrete urea. I suspect that my limits are more of the 55 to 60 in terms of the rate of mean rate of urea excretion, but everyone sort of falls on this graph. But you can see these are easily obtainable amounts of protein if we were only eating protein to get to the limit of what your liver can do for urea excretion. I did a whole debate on high fat versus high protein, which you guys can see. It was originally on the Better, Stronger, Faster podcast. I reposted it on my YouTube. That's me and Ted Naiman. There's a lot of abs in this picture. I apologize for anyone who's easily offended by abs. Me and Ted Naiman, I sort of took the position that high fat was something that would be valuable. Ted Naiman is perhaps, it would be an oversimplification to say this, but he's more of the position that we should be focusing on higher protein. So this was an in-depth discussion if you guys are interested in high fat versus high protein. I was not in that discussion, however, disavowing or de-emphasizing the importance of protein. I do think humans need protein. I just think that if we overemphasize protein at the expense of good quality animal fat, we are missing out on unique nutrients. So Miki also felt in this original paper that we talked about previously that there was a physiologic ceiling on plant food intake, and that it could be limited due to fiber or toxins affecting the bioavailability of nutrients, affecting digestibility. And as Miki says, and I would agree, the poor health status of present-day dieters who base their nutrition on raw foods, raw vegetable foods, manifested in subfecundity and amenorrhea is no joke. So this is really sort of my little interjection of my carnivore perspective. I do think that there are dangers to excessive plant consumption. This is not a whole talk on the carnivore diet. That one was at KetoCon. If you want to hear that one, it's listed in all my sites. But these are just a few of the articles that I've come across that I think are most striking, suggesting that specifically fiber overconsumption can be dangerous for humans. This is a very contrarian perspective and probably merits a talk all of its own. But dietary fiber intake increases the risk of zinc deficiency in healthy women, stopping or reducing dietary fiber intake reduces constipation and associated symptoms. That second study actually shows that the removal of fiber resulted in the complete resolution of idiopathic constipation in a moderately sized group of people. And then the last reference there, the effect of daily fiber intake on the reproductive function. They concluded that a diet high in fiber is significantly associated with decreased hormone concentrations and a higher probability of anovulation in women. So just fiber here, I would say fiber is not a nutrient for humans. Fiber is at best net sort of zero. It's maybe not harming us. And at worst, fiber is clearly detrimental to humans in terms of constipation, in terms of dysbiosis, in terms of hormonal changes, and in terms of mineral and vitamin bioavailability. So again, this is a whole separate talk that will piss a lot of people off and be super controversial, but I would say fiber is dangerous for humans and is part of the physiologic limit of human plant consumption. The other part of human plant consumption that creates a plant ceiling is the other anti-nutritional factors in plants, specifically polyphenolic compounds, which so many people consider to be valuable, but I would say are actually anti-nutrients. These are phytoagglutinins. These are plant defense molecules. Again, this is a whole separate carnivore talk, but the poor digestibility of protein in diets of developing countries based on cereal grains and legumes is due to the presence of less digestible protein fractions, high levels of insoluble fiber, and high concentrations of anti-nutritional factors. They're specifically talking about either digestive enzyme inhibitors or polyphenols inhibiting the digestion of proteins. So this concept is pretty radical. Polyphenols, tannins fall into that category, inhibit the digestion of proteins. These are anti-nutritional factors. So again, tons of contrarian statements, tons of controversial statements. I'll just drop them there and we'll move on. We can debate them heatedly in the question and answer session or after if you guys want to talk to me. But I do not believe that these are beneficial for humans in any way, shape, or form. And I think there's really good evidence they are a net negative for humans. Just another article to kind of drive that point home. The inhibition of digestive enzymes by polyphenolic compounds. So there are naturally occurring polyphenols, in particular condensed tannins. They have been shown to inhibit a number of digestive enzymes and could affect the availability of protein and other nutrients on a high polyphenolic diet. This is quite different than what many other people would say. Interestingly, there are many animals, the moose is a great example, that have compounds in their saliva that break down tannins because they are eating so many of these tannin-rich plant foods that they have to break them down in order to get the proteins out of the plants, which are not very nutritionally bioavailable. So some animals that are herbivorous and have consistently co-evolved with plants are now, you can see these anti-tannic compounds in their saliva. They have this defense mechanism to sort of counteract the plant defense mechanism. It's all this biological warfare. Unfortunately, humans don't have that in our saliva, and if we overconsume tannins, we are looking at potentially this problem. So again, this is the idea of plant physiologic ceiling to what we can consume. So where does that leave us if we can't eat a whole lot of plants because of these problems with fiber and anti-nutrients and polyphenols inhibiting digestion, and we can't go above a certain threshold for protein? What's left? Well, really fatty meat is left, fat and organs. So it's my goal in this talk to show as many pictures of steaks as possible. And lunch is coming up anyway. So, all right. But here's the problem, and I'm just going to touch on this for a moment. The Mayo Clinic, the powers that be, say that these types of fat are really bad for us, which is just silly in my opinion. And I think that I would refer people to a recent conversation that I had with Gary Fettke on my podcast, which is called Fundamental Health, if you want to understand perhaps some of the crazy, crazy origins of where these nutritional guidelines came from. But it is staggeringly incomprehensible to me why these major organizations, the AHA, the Mayo Clinic, continue to say that saturated fat is bad for humans, continue to say that animal fats are bad for humans, in the face of gathering large amounts of evidence to the contrary. And I'll just cite a few of these. Again, I don't want to go deeply down this rabbit hole at this point. So this is a study of 42 European countries. It's epidemiology, but they do not support an association between CVDs, which is cardiovascular diseases, and saturated fat. As they note, it's still contained in the official dietary guidelines. It says, instead, they agree with data accumulated from recent studies that link CVD risk with the high glycemic index load of carbohydrate-based diets. Well, isn't that interesting? Because if you don't eat a lot of fat, you have to eat a lot of carbohydrate. That's just how it works, because we can't eat a lot of protein. We know that because of the physiologic limits of protein consumption. So every time someone is advocating for a lower fat diet or removal of animal fats, they are advocating, at the same token, for an increase in plant carbohydrates. And that is maybe not a good thing. And I think that many studies are beginning to show this, but we are fighting an uphill battle in terms of the consciousness in the broader population. So I think I skipped one. Another study, pretty much the same thing. This is called the PURE study. High carbohydrate intake was associated with higher risk of total mortality, whereas total fat and individual types of fat were related to lower total mortality. The more fat, the less you die. Sounds like a good reason to eat a really fatty steak to me. More fat, less die. I like it. There's tons of studies like this. Don't have enough time to really go into all of them, but animal protein, animal fat, and cholesterol intakes, and the risk of cerebral infarction, there it says it all at the bottom. A high consumption of animal fat and cholesterol was associated with a reduced risk of cerebral infarction death. They're talking about stroke. This is published in the journal Stroke. So again, to imagine that there is a very clear representation in the literature that animal fats are bad for humans, that humans should not be eating these, that these are contributing to death, mortality, is false. There is some conflicting data, but I think that if we look at the general consensus of the data, it is clearly in favor of the fact that from an epidemiologic perspective and a mechanistic perspective, animal fats are only associated with better outcomes. Again, there's some nuance here, but in the face of such studies as this, I do not understand how the AHA and Mayo continue to recommend against saturated fat. That's all I'll say about that, and we'll go back to the regularly scheduled program. So where's the real magic in animal fat? I think that evolutionarily we can imagine that humans were seeking fat because it's calories, because we want calories. And that's totally awesome. And I think that that's an evolutionary thing. But there are very few humans on the earth today that are deficient in calories. We can get plenty of calories. The reason I wanted to do this talk was because I think that some of the nuance here is that there are unique nutrients in animal fat that we should not forget about. And I believe that evolutionarily, that huge uptick in the size of the human brain had more to do with these nutrients that are present in animal fat rather than the unique consumption of calorie-rich foods. It's not that we just need to go out and get tons and tons of calories. That's not so hard to do. But if we look at the way that nutrients are partitioned in animals, we find very interesting data about unique nutrients in animal fat relative to other compartments and unique nutrients in organ meats relative to other compartments. Again, this kind of goes back to my theme, way more than animal meat if we want to be healthy humans. So fat has unique nutrients, and that's why I put a unicorn on this slide, because I just like putting unicorns in my presentations, right? Because I like using the word magic and I like unicorns. Fat has unique nutrients. We're not going to be able to get into all these in the interest of time today, but let's talk a little bit about it. This is my premise, this is my postulate in this talk, that there are valuable nutrients in animal fat, especially properly pastured, properly grass-fed animal fat, that do not exist in as high concentrations elsewhere in the animal, and thus fat is a nutrient. Fat is a vitamin in sort of the most loose sense of the word. So we're going to talk about some fat-soluble vitamins. I'm not going to talk much about the omega-3 fatty acids today because that has been talked about many, many times over, but we can just say briefly that clearly grass-fed animal fat is going to have higher concentrations, though grain-fed animal fat doesn't have zero concentrations. It's just that grass-fed animal fat has higher concentrations of omega-3 fatty acids. There's a whole separate body of research to delve into there that we will pause and not look at today. Coenzyme Q10 is an interesting possibility because it's actually a fat-soluble nutrient. And then there are some trans fatty acids in animal meat that if we have time, we will talk about, which potentially have very valuable health implications for humans. Again, so this is the type of stuff that never gets talked about. People just think of fat as fat. They think of fat as calories, and fat will make me fat. But what's so interesting here is that fat has nutrients. So briefly, let's talk about this. This is a really cool paper comparing the amount of nutrients in grass-fed or grain-fed animals. And what it shows is that the antioxidant status, there's more glutathione in grass-fed animals, and they actually quantify the amount of alpha-tocopherol, which is one of the isomers of vitamin E, beta-carotene, and ascorbic acid in grass-fed and grain-fed meat. What we find is that there's a moderate amount of vitamin E in grass-fed meat, but they only measured the meat. They measured the muscle meat. They didn't measure the fat. And as an aside, I'll mention here that in the muscle meat, vitamin C, which is water soluble, it's actually a pretty decent amount. There's 11.3 milligrams per pound of vitamin C in muscle meat, according to this calculation. It's just so crazy to me that the USDA always reports vitamin C as 0 in muscle meat because they never measured it. So the theme here is that we just don't know what's in many of these organs in animals because the USDA has never measured them. So I want to show you a few levels in carnivores. This is actually my blood work. One of the criticisms of the carnivore diet has been that it's vitamin E deficient. Well, I'm above the normal range for vitamin E there. You'll also notice that my coenzyme Q10 is quite a bit higher than what True Health would say is their upper end of normal. Coenzyme Q10 is right there below vitamin E, and you can see my other blood work if you want there. But don't just take my blood work. Here's another carnivore's blood work that I work with. He has the same vitamin E as me, 22.9. And his coenzyme Q10 is even higher than mine at 3.6. And here is another carnivore, vitamin E 32.0, quite robust. So where's all this vitamin E coming from? It's coming from the animal fat, is my suggestion. That animal fat is a unique source of this fat-soluble mineral, this fat-soluble vitamin, I should say, and that we can get lots of vitamin E from eating animal fat. And as we know, vitamin E is an antioxidant, works in the human body in very valuable ways, protecting membranes. This kind of pissed me off. So somebody sent me this today in my email. This is an article in USA Today. I'll move through it quickly just to say that in this article, this physician who works for the Barnard Center the formatting on this didn't quite work out. He was saying that the only source of dietary antioxidants is through plants, and that was his advocacy for a plant-based diet, and I thought that is bunk. That is baloney, because as you've heard me talk about perhaps in other talks, or I can talk about in the future, if we actually look at the antioxidant status or the oxidative status of people eating lots of vegetables and compare that to the antioxidant status of people eating no vegetables, we see no difference. So in terms of interventional studies, there is no evidence that eating lots of vegetables improves your oxidative status at all, which is another very crazy statement. So no effect, 600 grams fruits and vegetables per day on oxidative DNA damage. Increasing vegetable intake, no improvement without modifying oxidative stress or inflammation in overweight or obese postmenopausal women. Just, I think if you guys are curious about this, I would recommend the podcast I did with Gary Fettke. This has to do with where the nutritional guidelines are coming from. And the Barnard Center is probably associated with the Seventh-day Adventists as well. It's a little bit of a strange sort of connection. So let's talk briefly about vitamin K. I'm kind of running out of time. Multiple forms of vitamin K, K1, K2, and K3, which is an intermediate. Chris Masterjohn has done a great post on his website. Chris Kresser has a great post about vitamin K. Basically, the takeaway with vitamin K is that vitamin K is another fat-soluble nutrient. It ends up in the fat of animals. If we look at where vitamin K is stored, it's in the fat. It's also in the organs, but it's especially in the fat, and it's in the fat in vitamin K2. So we know there are incredible results with vitamin K2 supplementation, and if we look at epidemiology, especially the Rotterdam study, you see this clearly. The more vitamin K2 people had, again, this is an observational epidemiology study, the more vitamin K2 people had, the less incidence of coronary heart disease and the less incidence of aortic valve calcification they had. But the cool thing about the Rotterdam study was that there was no association with phyloquinone, which is the plant-based form of K1, the plant-based form of vitamin K, which is K1. So this is what's so cool. This is in the fat. So vitamin K, you want to get vitamin K? Eat good animal fat. That's where you get it. It's also in other organs like liver, heart, and pancreas, but animal fat is a source of vitamin K, and nobody ever talks about this, and it's not measured by the USDA. So again, this is a study that showed the same thing. A high menaquinone intake reduces the incidence of coronary heart disease and no connection with K1, which is phyloquinone. So I'm kind of running out of time. Let's see what we want to do here. I talked about this a little bit. The sources of vitamin K2 are organ meats, brain, heart, kidney. Eat your organ meats. This is good for you. Even though they're weird and they're gross, they're so good. Animal fat, butter, cheese, egg yolks, emu oil, and the last one is my favorite, grass-fed ruminant fat, which is like suet and trimmings. This is the source of K2 that no one hears about. We're all told, eat your natto, when in fact, we should be eating grass-fed ruminant fat to get vitamin K2, but the AHA, Mayo would tell us that those kind of foods are going to be horrible for us, when in fact the epidemiology evidence speaks very strongly in favor of increased consumption of animal fats with decreased levels of coronary heart disease. And animal fat is this incredible source of that nutrient. So if you guys have not tried suet, you should try suet. It's amazing. It's a perinephric kidney fat. It's really good. I eat just like pure fat. I should have had a photo, but fat doesn't look really good in a photo. It just looks like fat. I don't have a ton of time to talk about fatty acids as signaling molecules. I want to allow some time for questions and answers. Briefly, what I'll say with regard to this is I'm talking about molecules like conjugated linolenic acid. This is a fatty acid profile from one of the people I know who's also a carnivore. What I want to focus on briefly is just the fact that you can look at the trans fats here. And conjugated linoleic acid is a trans fat, but it is not associated with the same negative consequences as elaidic acid, which is the trans fat that we get from plants or the vegetable oil fat, right? So there's a nuance here. And I don't think that the research is totally clear on what to do or what conjugated linoleic acid is doing in the human body, but what is very clear is that fatty acids are signaling molecules, that fats affect us hormonally, fats affect us in terms of genetic and epigenetic signaling in the human body. And that this one fat that we're talking about, which is in that sort of trans linoleic group, specifically conjugated linoleic acid, which falls into this category of ruminant acid in the middle here, is probably very influential in the human body. And I suspect, based on evolutionary norms, that it is affecting us in a positive way. It's difficult to study because there are many isomers of conjugated linoleic acid. And many of the studies only use one isomer, and they're not recreating the profile of conjugated linoleic acid that would be in animal fat in the same way. Vicinic acid is another trans fatty acid that's in animal meat that gets converted to linoleic acid, conjugated linoleic acid, and that's elaidic acid at the bottom. That's the one you don't want. But how interesting is it, how cool is it that the position of the double bond is what determines everything? Because elaidic acid and vicinic acid, ruminant acid, these are all 18 carbon molecules, and they just have double bonds at different places. Ruminant acid, conjugated linoleic acid has 2 double bonds. These other ones have 1 double bond. The space of the double bond totally changes the way this molecule affects our bodies and affects hormonal signaling in so many ways. So I'll just breeze through this and we can wrap up so that people can have questions. But there is a positive epidemiologic association between consumption of elaidic acid, which is the vegetable trans fatty acid, but not ruminant trans fatty acid isomers, which is interesting. There is some evidence that conjugated linoleic acid can reduce fat mass in humans. It's been studied to reduce weight and cause improvements in weight and insulin sensitivity. You can see the overall trend in this meta-analysis here is toward a negative change in fat mass. There are more studies needed here. The conjugated linoleic acid is acting as a signaling molecule. It does affect systems like PPAR, which is the peroxisome proliferator gamma, and alpha systems, which are involved in insulin sensitivity and insulin signaling as well. You can see this one perhaps can attenuate inflammatory markers in a colonic epithelial cell line. It's been studied. It affects PPAR alpha as well. It perhaps could affect things in inflammatory bowel disease models. And let's talk about some take-homes, and then we'll get to questions. Fat has been valued throughout our existence as the most valuable nutrient. It has been improperly maligned. The evidence that saturated fat animal fats are bad for humans is essentially misinterpreted and, I would say, shared with us in misleading ways. It does provide unique nutrients for humans, fat-soluble vitamins and minerals, vitamin E, vitamin K2, conjugated linoleic acid, perhaps others we're not even aware of. Coenzyme Q10 perhaps is stored there as well. And fat from grass-fed animals is a critical part of our diet. So if you want to stalk me, that's my podcast, that's my website, and I wish you all a sea of fat.
time. We have time for about 5 minutes, and then maybe you can answer some questions outside. Perfect. So 5 minutes.
Thank you for your talk, Paul. I don't know if you did this on purpose, but I heard you say something like vitamin K is in fat and other organs, and I think it's great to recognize that fat is an organ meat.
Yes, I couldn't agree with you more, Amber. Fat is an organ meat. And I wanted to say that in the talk as well, that fat is an organ. It's a hormonally active organ. Fat is an organ. I couldn't agree with you more.
I wanted to ask you a question about CLA because I have been trying to defend omega-6 fatty acids for a while. I've been thinking particularly about arachidonic acid, which is a really important omega-6, but I hadn't thought about CLA as one of those. And I'm wondering, I haven't looked into it very much. Is that something we can synthesize, or do we have to eat it to get it?
We can synthesize it. So it's present somewhat in animal fats, but mostly I believe ruminant fats have vicinic acid, and there's an enzyme in the human body. It's actually probably in one of those abstracts that we can synthesize the vicinic acid into various isomers of conjugated linoleic acid, yes. And similarly, to your point, arachidonic acid has hormonal effects as well on the PPAR system. So yes, I would agree with you completely. In my opinion, arachidonic acid has positive hormonal signaling cascade as well.
Cool, thank you.
Yeah.
I just want to welcome you to SoCal.
Oh, thanks. It's good to be here.
Yeah, no, I'm a big fan. And have you found a local butcher to?
I've heard people say there's Tip Top Meats or something. I'm trying to find a good butcher that has grass-fed meat. Yeah.
I want to try brain, and I can't find any.
I can't find. If you can find it, you need to tell me. I had
Okay.
somebody on Instagram send me brain. It was amazing.
That's what I've heard.
Yeah.
Thanks a lot.
Yeah.
Hello.
Hey.
What would you say to someone who's carnivore curious? I guess, like, to start.
Welcome to the tribe.
I haven't done anything yet. I'm just curious.
There's room for you here. I guess help me understand what I can offer to that. I mean, I think if someone is carnivore curious, there are a number of resources out there. I would say usually when people are carnivore curious, they have a few things that they're most concerned about. They're thinking, oh, I need fiber to poop, or I need or this or that. And I would direct them, if there were specific concerns that someone had that were were making them a little bit, trepidatious to take the leap and try it, then I could address those specifically. But I think that the interesting thing about a carnivore diet, and I've talked about this with Amber, is that it's generally, it doesn't have to be a dogmatic thing. I think that it's essentially a continuum. The more animal organs, the more animal meat that you include in your diet, I think that the more high density, nutrient rich foods you're going to get, and that's going to improve your health regardless. I do think that elimination of plant toxins is important for some of the reasons I mentioned, and that the magic is a lot of doing both, but I think that the more organs you can include in your diet, that's going to help you out, and the fewer of the triggering plant foods you can include, that's going to be good as well. And so it's just kind of this, it's two things, you increase one and decrease the other, and it doesn't have to be a complete, reversal, but I think moving in a direction with both can help you get to your goals.
Thanks.